All right, multi-step inequalities, we're not really learning anything new. We're just putting our single-step inequalities together. So everything that we have learned in the last two lessons applies here. So if we divide or multiply by a negative, we are still going to flip the sign. And, if we have to translate, right, the translations for all of our inequalities are the same as well. Okay, so when solving multi-step inequalities, it's just like solving equations. Okay, we want to get our variable by itself. So we would first add 13 to both sides to get rid of that, to give us negative 11y. Since we're only adding, we keep the sign, and this is going to give us 55. Right, I would divide both sides by negative 11, right, and end up with y. Since I divided both sides by a negative, the sign flips, and I get is less than negative 5. All right, we still have to graph. So remember, we put our number we get in the middle. Since it's a negative 5, greater than would be negative 4, less than would be negative 6. And since y is less than negative 5, it's that open circle with the arrow pointing to the left. All right, next one. Again, same thing. We're trying to get this variable by itself. So we want to get rid of the thing that doesn't have the variable first. So if we get rid of that, subtract 10, we're going to end up with 13 is greater than or equal to negative 2w. And then again, just divide by negative 2. Okay, so 13 divided by negative 2, we're going to get a negative 6.5, right? Or you could honestly leave it as an improper or write it as negative 6.5. Since we divided both sides by a negative, the sign flips, and we're just left with w. But remember, we want to write that variable first, so we're going to write it as w is greater than or equal to negative 6.5 is that answer. And then if I were to graph, I have negative 6.5, negative 6 would be bigger, negative 7 would be smaller. Since it's greater than or equal to, that is that closed circle with the arrow pointing to the right. All right, we may have some parentheses. Remember, when there's parentheses, to get rid of them, you just distribute. So we're going to get 12t minus 20 plus 7 is greater than or equal to 8t plus 3. All right, before we do anything, since there's terms on the same side that are alike, we want to combine those like terms. So this is going to give me minus 13, and I keep everything else the same. And then remember, when you have your variables on either side, we want to move them to one side. So like I'm going to subtract 8t from both sides. This is going to give me 4t minus 13 is greater than or equal to 3. And then we just keep solving. So I would add 13 to both sides to give me 16, and then divide both sides by 4 to give me t is greater than or equal to 4. All right, I'm going to add one more in just so we know what to do here because I saw some mistakes. Let's say I have something like this, right? X over 5 minus 1 is greater than 3, right? Before we do anything, we need to get this by itself, right? Because if we have this, right, if we were to multiply by 5, which you could do, everything has to be multiplied by 5. That's the step that most people forget, okay? In order, or maybe to make it a little better so we don't forget, if we add 1 on both sides, right, that gives me single terms on either side of my inequality, which makes it a whole lot easier to remember, right? Because now if we just multiply by 5, there's only 2 things we have to multiply rather than the 3 terms up here. All right, so we just need to keep that in mind when solving problems with that fraction and a number. Okay, we got to get rid of that number first, or you have to multiply everything by the denominator. All right, last two, we have some special cases. Right, just like with equations, we have special cases with inequalities as well. Right, so let's see what they are. Let's just go ahead and solve. Right, the first step we would have to do is distribute. And since there's two sets of parentheses, we can distribute both. So I'm going to get 9t minus 5t plus 25 is less than or equal to 4t minus 12. Right, just like we did on the last one, combined like terms is going to give me 4t plus 25 is less than or equal to 4t minus 12. Right, if we do the same process that we just did, and I subtract 4t from both sides, notice that they cancel, and we're left with 25 is less than or equal to negative 12. Again, when your variables cancel, just like with equations, that's our special case. Right, in this case, though, we don't have an equal sign, but we do have a statement, and it says that 25 is less than or equal to negative 12. Right, this statement is not true. Right, and because it's not true, this would be no solution. Right, and if it did ask you to graph, right, a no solution graph would just have nothing on it. Right, it would just be blank. Okay, so that's one of our special cases. Let's go ahead and solve this one. So if we solve this one, if we distribute, we're going to get 12m plus 18 is less than or equal to 42 plus, if we distribute here, 12m minus 24. Okay, combine like terms, which are like terms, are going to be 42 and 24. So I'm going to get 12m plus 18 is less than or equal to, if I do 12m, this gives me 18, I believe. Yeah. Right, again, if we were to subtract 12m, boom, boom, it's going to give me 18 is less than or equal to 18. Again, variables cancel, right? So we are left with this statement. This statement is true. 18 is less than or equal to 18 because they are equal, right? That or equal to matters here, right? So because of this, right, this solution is going to be our all reals or all real numbers, right? Infinitely many. And again, if we were to graph this, right, the whole thing would essentially be shaded with our arrows. Okay, the whole number line would be covered if it's all reals, meaning any number we plug in works for that inequality. Right, you may have some word problems as well, but the same translating applies, right? You need to know your at most, at least, is no more than, is no less than, and all of your operations.